Hello everyone, myself Yadagiri, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology. So I'm also the faculty of Basic Electrical Engineering. In the last session, we have discussed about the fundamentals in electrical engineering. Also, we can say electrical circuits, and also the types of elements. That is the types of fundamental element. That is RLC. So we have completed. So now we are going to discuss about in this session. That is the types of elements. Means based on their VI characteristics. So based on the voltage and current characteristics, we need to classify the elements in 4 categories. So that is the active and passive elements. The other one is the linear and non-linear elements. And third one is the unilateral and bilateral elements. And the fourth one is the lumped and distributed elements. So this classification we have done under the basis of their VI characteristics. So now coming to the first element, that is the active and passive elements. So in the active elements, nothing but so the active elements are elements which is capable of delivering the energy continuously to other circuit elements. Those elements are simply called as active elements. So active element means the element which can delivers the energy continuously for a long time. So those kinds of elements are in the electrical circuit simply called as active elements. So the best examples of the active elements are, so that is a voltage source. So voltage source is a one best example, and also the current source. So these are the, regarding the active elements, voltage source and current source. Active element is nothing but the element, it is a capability to deliver the energy continuously for a long time independently. So those kinds of elements are in the circuit should be called it as simply active elements. Now coming to the passive elements category. So the passive element nothing but the element is do not capable of delivering the energy, or so whatever the elements in the electrical circuit should consume the energy or power, those kinds of elements are simply called as passive elements. So the examples of the passive elements in the electric circuit, that is a resistor, inductor and capacitor. So these are the examples of active and passive elements. So again I'm concluding the active and passive elements. So active element nothing but so whatever the elements are can deliver the energy continuously for a long time to the other circuit elements. Those elements are called simply active elements. And whatever the elements are in the electrical circuit consumes the power or energy, those are called simply passive elements. Or also other words, we can define the passive elements. The element is do not capable of delivering the energy independently. So also we can say that is the passive elements. Now coming to the linear elements, the second category, there is a linear and non-linear elements. So linear nothing but, so this is defined from the VI characteristics of the element. So we would like to consider the standard plane. So whatever the elements in the electrical circuit, the VI graph should be passes through the origin. Means the element VI characteristics are should passes through the origin. It must be a straight line and also obeys the property of Ohm's law and as well as maintain the constant slope. So that kind of elements are simply called as linear elements. So the linear elements are nothing but are defined. So the element VI characteristics are should passes through the origin. It must be a straight line and obeys the Ohm's law and as well as maintain a constant slope of between these voltage and current. So those kinds of elements are in the electrical circuit should be simply called it as a linear elements. So the best example of the linear elements are, that is again voltage, current. Sorry, the best examples of this one is the resistor, inductor and capacitor. These are the examples of the linear elements. So the non-linear element nothing but so the element VI graph. So let us consider a VI graph of the particular element. So that is this is the voltage and this is the current. So this is the voltage, this is the current, this is the voltage, this is the voltage, this is the current, and the element VI graph should be like this. So the element VI graph means I am going to define the non-linear elements. The element VI graph may or may not passes through the origin. So it doesn't maintain any kind of constant slope and also does not obey the property of Ohm's law. So simply these kinds of elements are called non-linear elements. So we can go through the examples of the non-linear elements, that is PN junction diode, then silicon control rectifier, then transistor. So also we can consider the BJT amplifier. These are examples of the non-linear elements. So this is a discussion about the linear and non-linear elements. Simply we can define again the linear elements and also the non-linear elements from one sentence, that is the linear elements in the electrical circuits is nothing but So the element Vi characteristics are should passes through the origin. It must be a straight line and also maintains the constant slope and as well as obeys the property of Ohm's law. So this kind of elements are in the network should be called it as the linear elements, else non-linear elements. So the examples of the linear elements are resistor, inductor, capacitor. And the examples of the non-linear elements are the diode, silicon control rectifier, transistor, etc. These are the linear and non-linear elements. Now coming to the third category, that is a unilateral and bilateral elements. Unilateral, nothing but unidirection. So whatever the elements in the electrical circuits, simply accepting the charge flow or current flow in one direction. So those kinds of elements are simply called as unilateral elements. So the examples of unilateral elements, that is again a PN junction diode. It is a PN diode or PN junction diode. Then transistor. So transistor. Then silicon control rectifier, etc. These are the examples of unilateral elements. So now coming to the bilateral elements, means it's also called as the bidirectional elements. So in the electrical circuits, whatever the elements are, allows or accepting the current flow from the both the direction, from the both the end. So previously we can take a PN junction diode. So in the PN junction diode, the current flow is always happening from anode to cathode only. So that's why these kind of elements are called unilateral elements. Now coming to the bilateral elements. So whatever the elements in the electrical circuits, so that can simply allows the current flow in both the direction. Means let us take one element as a resistor. One element as resistor. So this resistor easily accepting the current flow from A to B. So then also the B to A. So these kinds of elements are simply called as the bilateral elements. Now the examples of the bilateral elements are examples of bilateral elements are, so that is again resistor, inductor and capacitor. So these are the unilateral and also the bilateral elements. So till now we have discussed about the active and passive elements and also the unilateral and bilateral elements and also the linear and non-linear elements. So this is the three circuit elements in the electrical circuits. So now the last one is lumped and distributed elements. So the lumped elements are nothing but in the electrical circuits. So the elements are having the small in size nature. The elements are having or maintaining the small in size nature. So which is used to easily physically separable from the design network. Those kinds of elements are simply called as it's a lumped elements. So in the electrical circuits, the elements are looking like having like small in size nature and which can easily physically separable from the design network. So those kinds of elements are simply called lumped elements. Again examples of this one is resistor, inductor and capacitor. So these are the three elements under the category of lumped elements. Lumped elements means these are looking like having the small in size nature which is physically easily separated by the design network. So these kinds of elements are called simply lumped elements. So whatever the elements in the electrical circuits physically cannot easily separable from the design network. So these elements are called simply distributed elements. So the elements which is in the large in size nature and these kinds of elements are easily not separable physically from the design network. So these kinds of elements are simply called as distributed elements. So the examples of this one is transmission lines, electrical. So transmission lines means the transmission lines are made up of the again resistor, inductor, capacitor. So these elements are equally distributed from the sending end to receiving end, but the elements are cannot visible and also cannot separable physically. So hence these kind of elements are called simply distributed elements. So this is the types of elements in the electric circuits. So based on their VI graph, we can classify these are into the four categories, that is active and passive elements, linear and non-linear elements, and also the unilateral and bilateral elements, and lumped and distributed elements. So these types of elements are classification of different elements. The next topic in this session we need to discuss, that is a classification of the different sources. So the energy sources are simply classified into two categories, that is a voltage source and the current source. So this is the basic classification. But while commencing the voltage and current source, so there will be the separate sources are there, that is independent and dependent sources. Means, so that is a fundamental sources we can say. The fundamental sources in the electrical network, that is a independent and dependent sources. So in the independent source we have the again two categories. So in the electrical circuits we have the two kinds of energy sources are there basically. So that is under the basis of their property. So these are the two categories, that is independent and as well as dependent sources. The independent sources are further classified into two categories, that is voltage source. So that is a voltage source. Then second one is current source, voltage source and current source. Again, these independent voltages are further classified into two types. So that is ideal voltage source, that is ideal voltage source. Then the second one is practical voltage source, ideal voltage source, and second one is a practical voltage source, ideal voltage source and practical voltage source. Also there will be a further classification in the current source, that is ideal current source, that is ideal current source. Another one is a practical current source. So these are the types in independent sources. Basically in the electrical circuits we have the two types of energy sources are available, that is a independent and dependent sources. And the independent sources are again further classified into two types, that is a voltage and current source. In the voltage source we have the two classification, that is the ideal voltage source and the practical voltage source. In the current source also same independent category, we have the two categorization. One is the ideal current source, other one is a practical current source. So the other one is the dependent sources. So dependent source also further classified into four types based on the voltage and current. So because the sources are only delivering the voltage and current only, that's why. So based on the voltage and current, the dependent sources are also having four categories. One is voltage dependent voltage source, other one is a voltage dependent current source, then third one is current to dependent voltage source, and the fourth one is a current to dependent current source. So these four classifications are there in the dependent source category based on their voltage and current. So now we need to discuss about each and every source in detail. So now we need to discuss about the first one is the ideal voltage source. So the ideal voltage source is an independent source. Ideal voltage source is an independent source. So it is delivering the always fixed or constant value of voltage to the load terminals. So this is the ideal voltage source. So this is the notation of symbolic notation of the ideal voltage source. So here the independent and dependent sources are, the existing nature should be like this. So this is the independent sources always existing in this shape, and the dependent sources are existing with the diagonal shape. So these are circle shape and this is the diagonal shape. So now coming to the first one, that is the ideal voltage source. So the ideal voltage source is an independent voltage source which used to deliver the fixed or constant value of voltage to the load terminals irrespective of the load voltage, irrespective of the load current variations. So this is the notation or symbolic representation of the ideal voltage source. Now after that we need to connect one load to this ideal voltage source. So that is a load terminal it is, and we need to connect one load as a resistor. So this is the load resistor as a RL. So this is the Vs, and the voltage across the load is again we can take it as a VL. The current flows to the load as IL. So this is a VL, means it is a voltage across the load, and we would like to perform the VI graph of the load. So this is the current value as a I, this is the V and this is the I. So irrespective of the current, so it used to deliver always the fixed amount of voltage to the load. So this is the property of the simply ideal voltage source. It is an independent source which delivers the constant or fixed value of voltage to the load terminal. So irrespective of the load voltage variations, this is IL we can take. So irrespective of the load voltage value, the voltage must be constant. So this is the characteristics of the load voltage for ideal voltage source. So why does it delivering this kind of voltage means? So it doesn't have any kind of internal resistance. So that R internal means internal resistance of this kind of source should be equal to 0. So due to the absence of the internal resistance, this kind of source are delivering or representing the fixed voltage characteristics, means it will delivers always the constant value of voltage to the load terminal. This is idle voltage source. So now coming to the second one, that is a practical voltage source. So the practical voltage source is a independent voltage source, so which delivers specified or reduced value of voltage to the load terminal. So this is the notation of the practical voltage source. This is the source voltage. So this is the internal resistance of the practical voltage source. After that, we need to connect one load to this kind of source. So this is the internal resistance. So this is the load element, that is RL we can take. So this is the internal resistance. So now this is Vs we can consider. So this is the voltage across the load. So need to analyze the voltage and current across the load means, so on y-axis we would like to take the load voltage, on x-axis we need to consider about the load current. So this is the ideal characteristics of the load for ideal voltage source. So this is the ideal case. So in the ideal case, VL value equal to the Vs, means the voltage across the load should be equal to the source voltage for ideal case. So coming to this case, it used to deliver the reduced value of voltage. So due to the presence of the small internal resistance, it used to deliver the reduced value of voltage. So the voltage across load is less than always source voltage only for this case. So this is ideal case, this is the practical case. So this is regarding the practical voltage source. So it is an independent voltage source which delivers the reduced or specified value of voltage to the load terminals with respect to the load current variations. So this is the characteristics of the ideal and practical voltage source. Now coming to the third one. So this is the categorization under the voltage source. Now we need to discuss about the third one. The third one is, so it is the ideal current source. The third one is the ideal current source. So the notation of ideal current source is, we need to represent like this. So this is the ideal current source. So this is the IS we can take. So ideal source presenting the infinite resistance across the source. So this is the R internal resistance, or simply internal resistance, or R internal. And after that we need to represent the same circuit with the load. So this is the ideal current source as the current as IS. And also this infinite resistance, internal resistance should be infinity. So this will also represent in terms of the open circuit. So both are same only. So these open terminals are offering the infinite ohms. So now these are the load terminals. So we need to connect one load here. So this is the RL. So regarding the source, it is a independent energy source which delivers the again fixed or constant amount of current to the load terminals. So irrespective of the load voltage variations. So whatever the value of load voltage, so but the current must be fixed or current must be constant. So further we need to draw the VI graph of these two. So this case, this is the voltage VL. So now this is the current IL. So irrespective of the voltage, the current should be constant. So this is the VI graph of the load for ideal current source. So it is an independent energy source which used to deliver or supply the fixed or constant value of current to the load terminals irrespective of the load voltage variations. So due to the presence of the infinite internal distance across the source, that's why it will deliver the fixed amount of current to the or constant value of current to the load terminals, simply load element. So this is regarding the third one, that is the ideal current source. Now coming to the practical current source, the last one in the independent category. So the practical current source. So the practical current source is an independent energy source. The practical current source is an independent energy source which delivers the reduced or specified value of current to the load terminal irrespective of the load voltage. So this is a symbolic notation of the practical current source. This is IS. So this is internal resistance across the source. It is presenting always higher value. So, and we need to take after this one load, that is a load circuit. So this is the internal resistance. So these are the load terminals, internal, and this is the load RL. So the current through the load resistor is always lesser than source current, always lesser than source current. Now need to draw the VI graph of these two. So that is take a standard plane. On y-axis we would like to take the load current. On x-axis we need to consider the load voltage. So this is the ideal load characteristics of the above element, means ideal current source. So for that we need to get the fixed amount of current. So for this case, practical case, we need to get the reduced value of current. So this is the reduced value of current. So at this point IL is always lesser than the IS. So this is 4 types of energy sources, that is the ideal voltage source, practical voltage source, ideal current source, and practical current source. So from this we need to conclude the point is, so the ideal voltage source has 0 internal resistance and the practical voltage source has a small value of internal resistance. So it is a small value of internal resistance in series to the source. And coming to the third one, the ideal current source has presenting always the infinite resistance across the source, means the internal resistance of this kind of source is a infinity or infinite. So this is infinite. So for practical current source, it would like to present always highest value of internal resistance across the source. R internal should be equal to higher. So these 4 points we need to observe. Now coming to the other one, so that is dependent sources. So in the dependent source also we have the 4 classification, that is a voltage dependent voltage source, and voltage dependent current source, and the current dependent voltage source, and also the current dependent current source. So this one voltage dependent voltage source, it is a independent voltage source, so whose values are depends on the voltage of other elements. So hence these kinds of sources are called as voltage dependent voltage source. So this is the symbolic notation of voltage dependent voltage source. So whose values are, so these are existing in terms of diagonal shape, and whose values are equal to k times of Vx, where so k is a constant, that is whose values are real number, that is 1 2 3 4 5 so on. So Vx is a voltage across other element. So Vx is a voltage across other element. So this is voltage dependent voltage source. Now coming to the voltage dependent current source. So basically it is a dependent current source. It's also existing in the diagonal shape, and which is represented by the arrow mark in the source. So this is the current source whose values are depends on the voltage of other element, means it is a k times of Vy we can take. So basically it's a current source, but it depends on the voltage across the other element or voltage across the independent source. So that's why these kinds of sources are called voltage controlled voltage source or voltage dependent current source. Sorry, this is the voltage dependent current source or voltage controlled current source. Now coming to the other one, so it's a kind of dependent source, that is a purely voltage source only. So it is a dependent voltage source whose values are controlled by the current flows through the other element or current given by the main source or main independent source. So hence that kind of source are called current dependent voltage source. So basically it is a dependent voltage source. So this is the dependent voltage source, so whose values are depends on current flowing through the other element. I mean current flows through the other element in the same circuit will decide the voltage value of the source. So that's why it's called current dependent voltage source, also named as current controlled voltage source. So this is the notation of the current controlled voltage source. So the last one in the dependent source category, so that is a current dependent current source. So basically it is a current source, so whose values are depends on the current flows through the other element. So k times of Iy we need to represent the current value. So k times of Iy is the current given by the main independent source or current given by the other element in the same circuit. So this K is a real number 1, 2, 3, 4 we can consider. So based on the requirement, we can take it as a K value. And this IY is a current given by the main source or current given by the other element. That's why it's called current controlled current source. So this many classifications are these kinds of 4 elements classifications are there in the dependent sources, that is a voltage dependent voltage source, voltage dependent current source, and current dependent voltage source, and also current dependent current source. So from this one only the independent sources are existing in the real life, but dependent sources are used in the electrical circuits. To analyze the circuit response in detail point of view, we can use the dependent sources. So this is the end of the session. So thank you one and all for this session.